wabarakatuh. So now let's go to part 3 of the chapter 8, operational amplifier. So what you're going to learn today is the type of op-amp. Okay, the first one is what we call inverting. Second one is non-inverting. The third one is summing, and the last one is buffer. Okay, so let's go to the one by one of the type of the op-amp. The first one where we have inverting amplifier, non-inverting amplifier, summing amplifier means it will do summation, integrator and differentiator. Okay, let's start with the first one, that is what we call inverting amplifier. When we call inverting means, so this is your op-amp. We have two type of input, one is inverting, one is non-inverting, and one is output. So when we call it inverting amplifier, so what does that mean? Means you're going to connect your input must be a sine wave because it will amplify your AC input signal. It will be connected to your negative input. So when your input signal, let's say this is V1, is connected at negative input, we call that one inverting amplifier. What happened at your positive will be ground, and we have a feedback here. So what is the role of feedback? To control the gain. So in between the feedback, you have one element called R2 or RF. So this is what we call feedback resistor. And where is your output connected? At the output here. Okay. So why we call this one inverting amplifier? Because your input supply is connected at the inverting input. So in between this point what we call virtual ground. Why we call this one virtual ground? Because if we apply two golden rules to design op-amp, what is the first golden rule? The voltage rule, where you are going to make sure the difference between this voltage will be zero. Means if you apply here 0 volt, this is directly to ground, right? So what will happen at the voltage at this virtual ground here? By rule number 1, the voltage rule, where you will make both voltage the same. So this one is 0 and here will be 0. So it's not directly ground, but it will make it 0 because at the input here is 0 volt. Why? Because you will try to make both voltage here, V1 and V2, will be the same due to the golden rule. So that's why we name here virtual ground. Okay, so now let's derive the gain. What will be the gain for this inverting amplifier? Why we call this one inverting amplifier? Because your inverting input here is connected to the input supply. Okay, so how you're going to find the gain? Gain is out over in. So this is a voltage amplifier, means V out over the input is V1. The output is V out. The input is V1. So how are you going to derive that one? Okay, by applying golden rule number 1. Golden rule number 1, that is voltage rule. So what the voltage rule says, we will try to make both voltage the same here. So here will be 0. What will be the voltage at this G point is also will be 0. So V1 will be equal to V2, that is 0. So once you define this one is 0, what is the golden rule number 2? There is current rule. Current rule says that the current entering the op-amp will be equal to 0. So this one I equal 0, I equal to 0. Number 3, where you're going to start to derive the gain. Derive the gain. So how you're going to derive the gain? So we are looking at the current here. So you're going to apply KCL. So here is I1. Going out is I2. This is the point G, virtual ground. And going out here is I in. So by applying KCL, I1 will be equal to I2 plus I in. So what will happen to I in? By applying the current rule just now, your I in is actually equal to 0. So how are you going to apply I2? you have a voltage here. So by applying Ohm's law means V1 minus, this is 0, right? Minus 0 divided by R1 equal to, then what is the voltage drop at I2 here? Means 0. This is the current of I2. This is I2. So 0 minus V out over R2. So once you got that equation, your aim, remember your aim, you want to find the gain. So your gain is equal to what? So you need to derive, to rearrange this one until you got your gain is equal V out over V1. So let's rederive this one. So it becomes V1 over R1 equal minus V out over R2. So V out over V1 equal minus R2 over R1. So this is actually your gain. So now what is the gain of inverting or non-inverting? Gain of inverting amplifier, that is AV equal minus R2 over R1. So the gain is derived now. Okay, from the gain that you got from your analysis below, your gain is only depend on what? Your gain is only depend on the external resistor. Where is your R2 here? So your R2 here is the feedback resistor. Your R1 here is the resistor connecting to the input. So how are you going to control the gain from this circuit? You just need to vary R2 and R1. Okay. Okay, so if we look here, this is your gain value. Your gain value is AV equal minus R2 over R1. Okay. What will be the input resistance then? Where is your input? Your input is only R1, V1 over I1. Your output is actually R2. So there's 3 important points here. One is voltage gain, second is the input resistance, and the third one is output resistance. Okay, so let's try to solve one example. So this is, first you need to identify whether this is inverting or non-inverting. So you check the input, V1 is connecting to inverting amplifier. So this is inverting amplifier. So you can just use the formula. The gain is equal R2 over R1. Means minus 150 divided by 12, and then you get minus 12.5. Do gain have unit? No. So what does mean by 12.5? So you apply here 12.5 volt as the input. Add here. What will be the output here? Your V out here means you know your gain is equal V out over V in equal minus 12.5. So you can get V out is actually 12.5 multiplied by V in. So if I change this one, so if let's say you apply here 1 volt, so 12.5 multiplied by 1, so your amplitude or at the output, this is your V out, will be amplified by 12.5, but it will not change the shape. So this is the role of your inverting amplifier. Okay, please take note that your gain is having minus here. So what does that mean by minus? Is let's say you apply your input 1 volt, so your V out will having minus in front, right? So means the output will be inverted and amplified. So let's say this is your input, your output will be inverted and amplified. So this is the role of inverting amplifier. Okay, so if I apply here 1 volt, here will be minus 12.5 with the gain of 12.5. So your output for inverting will be inverted. Okay, as shown here, this is the output from oscilloscope. So what is oscilloscope? Oscilloscope is to display any signal that depend on time, any AC signal or AC waveform. So you know your op-amp, your input must be an AC signal, right? So how are you going to display your output, whether it is amplified or not? So you need to have oscilloscope. So if you see here, there is a blue and red one. So your V in is 1 volt, and your V out is actually 6.8 volt. And you can see the shape will be inverted, means that this is inverting amplifier. So that's all for inverting amplifier. So for the next video, we will move forward to the non-inverting amplifier. So as the conclusion, what is inverting amplifier? Always check where is your input connected. So here your input is connected at the inverting amplifier input. So this is what we call inverting amplifier.